Hello, welcome to my presentation of NOOPS, a visual query system for pattern search in multivariate time series. I'm Yunchong Yu from IAV, the technical solution provider, and from VIG at Utrecht University. So nice to have you here. Now, we can see a freshly started instance of the app. On the left side, you can see a sidebar with the workflow. On the right side, you can see some fields for inputting the data and metadata. Allow me to provide a directory containing the data. Then, let me provide a file containing the metadata. It tells us which checks are there in the data. After that, let me choose a file to inspect. Additionally, we need to specify the checks in the data to inspect. Otherwise, there can be too many checks. Now, let's plot the selected checks in the selected file. The two checks are extracted and anonymized features from our engineers. They correspond to the engine rotational speed and the acceleration. Our engineer wants to search for such an event. It represents the transition between half-engine operation to full engine operation in an engine of variable displacement. Let me mark it as the query to search for. Without further ado, let's just start the search. Well, you can adjust the position and the size of the query in any check, like this. The relative width here means that the time spans of the font patterns should be at least half so long as the query and no more than double the length of the query. It seems that the results are ready. Let's inspect the results. We can see 4 views in each data. The first one, analysis view, is kind of advanced and can be overwhelming with too much information. Therefore, it is collapsed at the beginning. The overview here shows the data and the font patterns. The font patterns are also extracted and listed in the font patterns view. They are listed in descending order of their confidences. Finally, we see the user labels view. It is empty now because we haven't provided any user feedback yet. Let's go over the font patterns and provide some feedback. This must be a true positive. It is also a true positive. Same here. This is also a true positive. and this must be a false positive. Sometimes we need broader context of the patterns for a better decision. In such cases, we may double-click a found pattern to highlight it. Then, we can locate it in the overview, possibly with the help of the minimap. You may have noticed the overview has an additional check with the confidences of the pattern candidates. The user can adjust the confidence threshold in this check. For example, we can filter this false positive out. Or we can add more found patterns if we like. Now, let's open the analysis view. There are 3 diagrams in this view. The histogram on the left shows the confidence distribution of all pattern candidates. You definitely want to set the confidence threshold higher than this dense region, because target patterns are usually sparse in the data. If there is a tiny cluster of top confidences in the histogram, as it is indeed in this case, it is often a good idea to set the confidence threshold just below this cluster. Then we get mostly the true positives. We will also adjust the number of found patterns directly in this input field below the histogram. It is often a headache for such retrieval tasks to identify false negatives and false positives, namely the missing patterns or the irrelevant hits. We use a dimensionality reduction scatter plot to find the false negatives. In this scatter plot, each point represents a pattern candidate. You can also see the query and the found patterns. The essence is similar patterns are close to each other and dissimilar ones are distant from each other. The user may check the candidates that are close to the query or close to the true positives to examine the potential false negatives, like this one. In this case, it is just some noise in the background. You can choose another dimensionality reduction technique, or just recalculate it, in case you believe that certain phenomenon is an artifact caused by some dimensionality reduction techniques and you would like to avoid it. On the right, you see an interesting force-directed graph. It shows the query and the font patterns. Similar patterns or nodes attract each other and dissimilar ones repel. It is used to find the false positives. Ideally, the query and the true positives build a cluster, and the false positives are distant from the cluster. Note that the dimensionality reduction scatterplot has similar function. However, in contrast to dimensionality reduction, the false graph works well when the number of instances are small. Moreover, it is interactive, meaning that you can move the nodes and sense the robustness of the visualization yourself. Okay, I will stop here for the analysis view. We can inspect the labels or the feedback we have provided in the user labels view. That said, labels do not need to come from font patterns. We can also mark labels spontaneously in the overview. Suppose you are lucky and you have found a target pattern. Of course, you can label it as a positive label spontaneously. Or, very useful, you can mark a long negative label. So that the model knows the background better and learns to differentiate the target patterns from the background better. You may notice that the user labels from the font patterns are lighter and the spontaneous user labels are darker. That's because the labels from font patterns have the originating font patterns in the background as a reference. Apropos, as you can see, we can adjust the labels here. Sometimes the search result is unsatisfactory, as in the case of the second file. In this file, the initial search has discovered 2 true positives. The rest are false positives. In this case, there are many missing patterns or false negatives in the data. We may lower the confidence threshold to find more patterns, but that would introduce many false positives. It seems that the initial search fails to separate the target patterns from the background very well. That's why we need the feedback-driven search. Okay, very briefly, let's inspect the last file. We can see 2 true positives here. However, we see also false positives with higher confidence. At this point, we have inspected the results and provided our feedback. We can start a feedback-driven search. Actually, let's just start it. Okay, here comes the result. There's not much room for improvement in the first file. The 4 true positives are retrieved again, and we have 1 false positive. The fourth graph also suggests this decision. We removed the dimensionality reduction scatter plot because there are usually not many pattern candidates after the feedback-driven search, so dimensionality reduction does not work well. Instead, we show the confidences of the time steps in each found patterns. Sometimes this visualization gives hints at the erroneous stage in the algorithm pipeline. Please refer to the paper for more details, because a deeper understanding of the algorithmic pipeline is a prerequisite to understand this visualization. Now, the exciting moment. Can we witness an improvement in the second file? Well, the result is unsatisfactory. Actually, let's first revisit the result in the second file. Well, that's the result. We have 2 true positives, some false positives, and possibly some false negatives in this large area. After the feedback-driven search, we have 3 more true positives and no false negatives. Actually, no false positives. That's a big improvement. The false negatives are found and the false positives are filtered out. And in the last file, we have only the 2 true positives. We can iterate the feedback-driven search multiple times, but let me stop here. This is a short, quick tour of NOOPS, our visual query system for pattern search in multivariate time series. If you are interested in our tool, please check out our paper. Thank you very much for your attention.